And if that was quick, hello everybody. This is an impromptu Science Sunday. I decided today to try and do some more solar projection because it was relatively nice out. There were some clouds, and you'll be able to see some of those clouds on the solar image. I didn't do a perfect job. I didn't take the reflection off of the white table, so the images aren't quite as clear as they were when I did this sometime last year. But today we have Abraham.
Hello.
We have John May.
Nope.
Okay. So we still have room for a few others, or 6 others. And I did open up the questions and answer app just in case somebody's watching from the outside and they'd like to ask some questions. So what I did today was I tried to align the telescope so that I could only use one control. So let's, I'm going to try and find that one picture for you that shows that very quickly. I hate to scroll through without. Okay, so, okay, there it is. So before I even put the telescope onto the mount, I used the compass to try and point this thing towards north. But I did move the tripod afterwards, which I think misaligned it because I was still using 2 controls. Nevertheless, I got some pretty interesting images. Not a lot, not the filament that they're saying. I don't know if you've seen the last few weeks they've been reporting this filament thing going across the sun. So I didn't get anything that detailed. And certainly the photos that I took are from a 2-megapixel tablet camera. So even the images that I was seeing live were better than the images I'm about to show you. And I apologize for that. But mainly, I just wanted to sort of encourage everybody to see how it is to do science in your own backyard. This is what I do. I have a inexpensive telescope, and I use it to not only nighttime viewing, but I also project the sun. And sometimes what we call daytime astronomy, looking at the sun, is one of the easiest things to do. Just beware, of course, never look at the sun, not even with your naked eye. If you're going to use the telescope to look at the sun, you need a solar filter, a full aperture solar filter, which I don't have. Therefore, what I do is I project the sun, never ever looking through the telescope at the sun. So this is one of the first images. Actually, I think this may be backwards. Let me see. If anybody has any questions, there's some of the sunspots there. Now, I do have a couple of photos that I fixed to get them a little darker. There is actually some other sunspots going on over here that this image does not quite show. And again, the images were better live than they were on this. So I apologize for that again. As you can see, those same sunspots are still there. Now, there was this line that goes across the screen, and I don't know why that's there. I don't know if you can see it. I'm thinking that it's the reflection from the table because of that line that's vertical. It might have been twisted. So there's that same line. That's not the paper. The paper is a flat sheet of paper. So there should be no seam. Very strange effect. I think, again, I think it had to do with the fact that I didn't shield the table. Okay. So as you can see, there's this fold in the table. It's just a basic folding table, $40-something at Walmart. The clipboards are literally putting weight onto the cardboard because I live in the shore area. And the slightest breeze blows this thing down. It is, after all, just a display board, cardboard from Elmer's. Okay. So here's one of the images where the clouds are in front of the sun. And at one point I couldn't see it at all. but I could still see it with the naked eye. Again, I didn't actually look at it until it was completely covered by the clouds. I did point the camera at it and take video of it, and if I get a chance, I'll show you that. Still waiting for anybody to ask any questions, or if you like, I can explain to you what telescope I have. I don't want to be the only one talking here. The telescope I have is a basic refractor. I'm using the 25 millimeter eyepiece, which essentially is only about 30-something power, but actual magnification is more because it depends on how far away I pull the screen away. The closer the screen, the smaller the image. This is when I set the camera to a different setting. I try to see if I can get it to show more by using a different color. The camera has some settings. And since I'm the only one talking, I'm going to stop a minute and I'm going to see if everybody left me. Oh, we still have people. Johnny May left.
We're all still here.
Yeah. Oh, except for John. John left.
Yeah, John.
All right. Well, let me mute for a minute because I have to clear my throat because I'm starting to get a little dry.
Yeah, well, anyways, to kind of continue off of that, if you're doing sun projection, one thing that you could do very easily, if you get all the kinks worked out and you get a decent enough image where you can see the sunspots, like in the photo that Patrick is screen sharing right now, you can see right there that there's a sunspot. Something you could do is just get your setup and once a day take a few pictures of the sun that you're projecting, and you could actually track the sunspot going around. And essentially, this is one thing that astronomers do every day is they track the sunspots. And I really don't know too much about that, but I know that it plays into their understanding of the sun and also the magnetic fields of the sun. So essentially, a sunspot would be a section of the sun which is cooler than the rest. And if I remember correctly, sunspots are basically just magnetic fluctuations on the surface of the sun, if I remember right. But anyways,
I think there's more to it than that, but definitely that does play into it. Yeah.
Right.
Yeah, sounds pretty good. Thank you for that. Again, I do wish these were clearer, and I think part of it is the fault of me. It was a spur-of-the-moment thing. I decided to look up at the sky, and I realized it was mostly clear. There was some clouds going past the sun a couple of times, but I decided to grab the table, grab the telescope, and unfortunately for me, I don't have a permanent setup. I have to literally take the telescope out and unpack everything as I do it on a day-to-day basis. So unfortunately, I don't have the what's the word I'm looking for? I don't have the luxury. That's the word I'm looking for. I don't have the luxury of just leaving the telescope there and just going back to it the next day, sort of thing.
I think that's pretty impressive, still, Patrick. I like your little setup there. Like, I mean, it's effective.
Yes.
You're able to use something of. I mean, it's just a piece of glass with a couple lenses in a tube, and you're able to produce a legible image. I'm kind of curious. Do you have any filters that you're using to dampen down the image at all, or is it that's a raw image?
That's raw. That's raw. I do have one image that I adjusted the color. Excuse me. If you look on my YouTube site, I could probably pull up the pictures if I have a few minutes of my first time last year when I did this, where I had a green felt on the bottom to stop the reflectivity. And
okay.
I adjusted all these pictures, and I was actually able to show the comparison to the professional satellite images, to the images that I had, and show the same area of sunspots. Unfortunately, this time it didn't come out so clear. There was this filament that they were showing that's been coming around every day, every other day or something. That I've been noticing on my Google feed that I have not been able to catch this time. And again, I think partially it's my fault for not covering up the white table. It's causing.
Yeah.
You can see the bottom of the screen is very white. It's shadowed.
What about, and this is just me throwing out an idea, possibly putting a cover like you've done at the top of the scope, if you were to put one at the other end, at the eyepiece, possibly to block any light coming from that direction. It'd make it harder for you to necessarily see if maybe you made a peering hole, a hole of some sort.
A cone over it or something, right? That's an idea. I don't know if it'll help at night.
I think maybe if you got a cardboard box and painted the inside of it black, and then maybe just on one end white.
Oh, yeah.
Well, it's a display board that you could get.
Yeah, yeah. But if you got maybe a refrigerator box and placed your telescope inside the refrigerator box.
Well, at least the end of it that projects the image.
Yeah, so to the point that, yeah, exactly, yeah, to the point that you're confining the amount of light that comes into that booth.
I see what you're saying. In other words,
Yeah.
Over the eyepiece, you know.
Right. Yeah, and you could just have a little viewing slit where you could maybe poke your camera through and take a picture.
A black curtain or something.
Yeah, and you could just get a black cloth and put it over the camera to minimize any light coming in.
Yeah, you could imagine. I think it'll be more effective if I was able to be in a box, because you could imagine taking pictures of this.
Get a refrigerator box.
I could not see the screen of the tablet, at least not very well, because basically I had the sun on my right side of my face, and I was trying to see what I'm actually pointing the camera at, you know.
Yeah.
So it wasn't exactly easy to see what I was doing. Let me see if I can show you. This is I did this a quick job of this. Basically, I darkened it, sharpened it, you know, things like that. I think you could barely make out. There is definitely some visible sunspots over here. When I was looking at it, that didn't show up on hardly any of these images, unfortunately. Again, this is a 2-megapixel camera taking a picture of a screen that's been projected from the sun. You can imagine how much better this would be if I could put the camera at the eyepiece.
Yeah, definitely.
Yeah. That spot is a bee flying by me. That is a bee that was attracted to the soap I'm using or something. It kept bothering me. Yellow jacket or some kind of bee. It stung me though, so I guess. Yeah, so again, that's the same sunspot.
How can you say that? When you show me one thing in here we can live without.
Okay, so this is live. Whoever's broadcasting something, I've got to be careful. I have to mute you.
Graham.
Graham, I think.
I'm sorry, I missed something.
I'm sorry, Graham. I had to mute you because this is.
No, I apologize. My girlfriend is watching The Big Bang Theory.
Oh, okay.
All right.
Yeah, because I don't know. You know, this is live, and I can actually get in trouble for that. They could flag me for that. All right. Okay, where was I? Oh, Hades' son showed up. There we go. How you doing, Hades?
Hey, Hades.
Okay, so where was I? I was trying to find an image that might have been more. Okay, I know what I was getting at. As you can see, this image is no more than, I don't know, 15 inches in diameter, maybe 15, 14. Whereas the first time I did this last year-ish, I had it as big as 17 or 18 inches in diameter, maybe even 19. But again, I had it more in the shadow of the house. As you can see, the sun is beginning to go onto the screen as well as the telescope, so it was more difficult. And it was closer. So the further I pulled this away from the telescope, the bigger the image. Even though I'm only using a 25 millimeter eyepiece, I could have used a bigger eyepiece, but I decided against it. It basically the 10 millimeter is 90 times, and it almost doesn't quite fill up the image of the entire field of view. But it would be harder for me to focus. It's harder to adjust without shaking the telescope every time you touch it, that sort of thing. So the best way to get the image to be larger is to simply pull the screen away. At one point I had to. I think this is starting to get too sunny. So at one point I actually grabbed the table and pulled it as far back as I could, and the image got a little bigger. I think, as you can see, the shadow of the house is going across the back of the table. Let me see if I can see a point. I can't tell. I can't tell when I did it and when I didn't do it. But in any case, anybody have any questions maybe about the telescope? Again, it's a 90 millimeter aperture. Let me get back to that.
Actually, Pat Hades has a question.
Oh, okay. I'm just trying to get back to that picture. Where the hell is that picture? I'm past up. There it is. Okay. There's the picture of the actual telescope. Okay. Let me see if I can. I guess he must be typing it in. I have to get back to that screen. Oh, he has it on a side chat. Can I ask you a question? Anyone see chat? Ask Pat about black holes. Fascinating. Okay. Anyone see what chat? Okay, this chat? Yeah, I do now.
Yeah, that would be group chat that he's talking about.
I had the question and answer app up, and I didn't have the side chat up, so I'm seeing it now, Hades. I don't know if you have any audio problems that you're not able to speak, but that's okay. What is it that you want to know about black holes? What that has to do with the sun? I can tell you that our sun will never become a black hole. In fact, it's small enough that it would never even go nowhere.
Black holes are formed in supernovas, I believe. So supernova is basically when you have a supermassive star, and essentially the way that stars work is by fusing elements together. That's how they get their energy. And eventually the star gets to the point where, obviously if you're fusing elements together, they get heavier and heavier, you get heavier elements. It gets to the point where this star starts producing the element iron, and the energy required to fuse iron together is more than you get out of fusing it. So essentially this is the death, if you will, of the star. So so in order to maintain fusion, you need to maintain some internal pressure in the star to keep the star from collapsing in from gravity, because the force of gravity is so strong. So once the star starts producing iron, actually, gravity eventually just takes over, and you get this as the star starts to collapse in, you get this massive heat, essentially, which blows out the star from the inside. So at the same time you have all this matter trying to go in, actually produces a lot of heat, and that forces everything out in this massive explosion. And that actually, so that's one thing that can happen. You can have this supernova where the star just explodes, and so that's one way it can go. The other way it can go is that the force of gravity is too strong and it just collapses into a black hole.
Yeah, if I may elaborate on that. The fact that our sun is specifically a G25, it is too small to go nova at all. And as I believe it was Abraham was talking just now, as he mentioned, once a star fuses together iron, that's basically the death throes of a star, of almost any star. It does not have the gravity. You just cannot fuse together anything other than iron. You can't fuse together two iron atoms together. It's just you just need too much energy. But when that does actually happen is during a supernova, because during the explosion many things fuse together, including iron, and it gets thrown out. That's where we get all of our radioactive elements and stuff like that. But our sun is too small of a star to do that. Our sun is going to die essentially, if you know anything about the Ring Nebula. It's M I forgot the number. In any case, it's essentially a small star like our sun has ran out of all of its fusible fuel, and basically grows into a red giant. It outgasses some of its outer core, and it leaves behind, very quietly leaves behind a cooling white dwarf star, which is essentially how our sun is going to go.
Right.
We'll
And
go
to
a red giant before it finishes off.
yeah.
She does a
And to answer Hades' original question, since black holes are essentially not this piece of matter, they're actually the opposite. They're this hole in space. We don't measure it the same way we measure an object with mass. So if you were to ask how big a black hole is, you would measure actually the radius or the diameter of it, much like you would measure the size of a circle.
Right. Essentially, a black hole is when gravity from the surface of an object reaches the speed of light. Presto changeo, you have yourself a black hole. Now, the radius, as Abraham was saying, of that black hole is essentially the radius at which, the diameter or the radius at which, light cannot escape. You don't actually see a black hole directly. What you do see is
right.
the horizon and things that are coming off the outside.
Yeah, and the more massive a black hole is, so that is one way to describe it, because black holes suck in matter and into essentially a single point, which is the best way to describe it. We don't know if that's how it is, because so when we look at the size of a black hole, Patrick is right. We're not actually looking at the black hole. We're looking at the point where light cannot escape the black hole. So we see essentially like this barrier of blackness.
The event horizon.
Right.
Also, now that they're doing more than that now, though. They're starting to see things that they didn't expect. Just like quasars and gamma ray bursts, they're starting to see these jets of energy coming from the poles of the so-called black hole. Again, you're not actually seeing it from the inside of the black hole. You're seeing it from the edges. And I'm not exactly sure how they explained it, but they're starting to see more now than they used to describe it as. But that gets into, I'll start needing a PhD before I can explain that to you. So but it's fascinating because there are different types of black holes. There are stellar mass black holes, which are stars that were literally only several times heavier than our sun, that were able to collapse to the point where, where the escape velocity became faster than light, all the way up to supermassive black holes like the one at the center of our galaxy, or any spiral galaxy for that matter, which are billions upon billions, perhaps hundreds of billions of the mass of any star. Billions of solar masses. Let's put it that way. These are the engines of the spiral galaxy. So that's a very interesting subject. But the thing is about studying our own sun, and even though it's a very cheap way of doing it, the way I'm projecting this sun, as I get better at it and create more shadowing so I can get a better image, you have to remember that it's the study of stars themselves, and what better way to study stars than to study the one that is so close to you you can literally see the sunspots. If higher magnification, you may even be able to see some flares and stuff like that. When you study the sun, you are studying a G25 yellow dwarf star, our star, the sun. So it can be a rewarding thing to do. It can be a bit frustrating when you're trying to take pictures off of a screen that you created out of cardboard, but nevertheless, it can be fascinating, especially if I were to get a solar filter, which would be a full aperture solar filter, and I would be able to put my eye actually at the eyepiece. But until then, until I get that solar filter, I cannot do that.
So, I have a question. In order to project the sun onto the paper, do you have like something attached to the eyepiece, or is that just standard on the eyepiece?
Nope, nothing special. It is you can use a pair of binoculars, close off one of the binoculars. You can use a small telescope. You can use a pinhole projection, which doesn't give you any kind of detail at all. It's only good for barely watching solar eclipses. One of the great things about this, and I can actually see detail, and I can maybe I should show you some of those other images from the last year's trial. But even if I wasn't able to see as much detail as I'm seeing here, what better way to spend it? What if, you know, I mean, if you got lucky enough and it was summertime and it was warm out and there's a solar eclipse, this is like a theater. Pull the box back far enough, and you've got a 20-inch in diameter sun that you can sit there and watch the Venus transit or the solar eclipses or whatever else is happening. You could be out there barbecuing and having a summertime fun while watching the sun go through its eclipse in a theater-type situation where you have an audience instead of people lining up at the eyepiece trying to see one at a time. So it's kind of my idea was to, I mean, I couldn't say it was my idea, but my idea for myself was to be able to show this to a lot of people all at once.
Yeah.
Certainly it's not an idea to project the sun. I mean, there's a lot of devices that you can buy out there that you can project the sun and watch. They have these little...
Right, right, and there's some multi-uses telescopes. They're pretty expensive. They cost a few $1,000s, but there's a really wide array of things that you can do with telescopes such as those. If you have
this telescope was $350 with all the extra eyepieces I bought.
Right. Yeah. So this is a relatively cheap. It's a pretty solid setup, though, I would say. But if you want to have like if you have a digital telescope, you could probably hook it up to a computer, and maybe if you have a projector, just project the image, and maybe do something like that.
In fact, the same place that sold me the telescope, Orion Telescopes, it's in California. If you come from California, you probably know about them. They have webcams attachable to the telescope, specifically for the telescope. So instead of the eyepiece, you put the camera in, and you'd sit there and put it on your computer. It's a beautiful thing. I just ran out of money, and I stopped buying stuff for the telescope, so including solar filters. One of the things I wanted to get was a solar filter. Another one was a light pollution rejection filter I never got. Quite a few other things that I never got for this, but I did manage to get myself a couple of eyepieces. In fact, I'm going to stop talking about what I got, and I'm going to actually show you. So I'm going to stop sharing this particular photo for now. I'm going to go back to my photos and look for the last year's project. Let me see. It would be on my desktop, I believe. I'm going to find it while you go ahead and ask me some questions or say something while I look for what I'm doing here. Oh, here we go. Desktop. How to solar screen is last year's project. Okay.
Hades, do you have any more questions? In the meanwhile.
Okay, so this is a full aperture. Let me share this. Okay, so this is a full aperture solar filter for my telescope, and let me see what else I can show you. This is a screenshot of somebody to show you that why you don't put your eye against the eyepiece of projection of the telescope, because you can see he's burning the paper there. This is the idea of a pinhole projector. This is another guy's idea of how to project the sun with a similar telescope, and he's got this here bucket thing going on. This is a screen, rear projection screen material you can buy. Hey, this guy's from Europe, I believe. This is a much smaller image. You know, the idea I like to do is get the large image so you can see the sunspots. This is one of the devices I was talking about, the Sunspotter. I forgot who sells this. I think the actual company is called Sunspotter. But again, it's a smaller image. It's very clear. It uses a very small lens. Okay, so there's many ways, and of course, I was explaining how I made the screen that I made, and you can see I bought the Elmer's Tri-Full display board and all that stuff. Let me see if I can find. Okay, this is how to point the telescope at the sun without actually looking at the sun. And I was telling you about in my original. I left a find. This is the finder scope. In itself, it's a 7 power telescope in itself, I think. So I left that off. You don't need that while you're projecting the sun. It's best to leave it off if it comes off, so that you don't get tempted to look through the viewfinder. This is the star diagonal that gives it the right angle, and this is the 25 millimeter Plossl eyepiece that I actually used. Okay, that's what I was looking for. I was looking for this. This is what I actually used. Now it's possible to damage this eyepiece with what I'm doing. I don't know if you realize that. Anyone? Is anybody still there? I'm not talking to myself.
Yeah, we're still here.
Okay. Yeah, it is possible to damage the eyepiece by doing what I'm doing.
Really, how does that happen?
Well, because especially if it's best to use the lesser eyepieces, the cheapest ones, because they have less elements, less glue in between, less whatever in between, less places for light to get absorbed the heat. So it's possible.
Oh, okay. Yeah.
Possible that I'm actually heating up the inside of this lens because a Plossl eyepiece, which is a standard nowadays, and compared to about 20 years ago or more, 25 or 30 years ago, I had a telescope, I had a Celestron. To get the Plossls was extra money. They gave you the orthoscopics instead, So the Plossls were the higher end. Nowadays, there's even higher than that. So. But that's what I use because I seldom use a 25 millimeter. If I do go out to look at the moon or something, I might. If I'm looking at some nebula, perhaps if I can get my telescope to see some of those nebula. A 90 millimeter telescope is not exactly a deep space image telescope, but it's an f10 point something as opposed to the 11.4 that the Celestron 80 millimeter telescope was. So it does gather more light than the 80 millimeter I had. This is the older videos that I did. Now you can see the last time I had this green on here, it was an attempt to darken up the bottom of the screen, which it worked. As you can see, it's on the ground rather than being, on the table. That's what I did last year, and last year's sunspots were also a lot more, and I think there's some fixed photos, as you can see. Fixing the photos, you see a lot of sunspots from last year's. Okay, you can see the difference. So yeah, you can see the difference it makes to really get a dark screen. It makes a big difference in trying to really see the. This is about the solar glasses. It makes a big difference to that's my telescope. It makes a big difference to be able to. I guess that's the end of that particular slideshow. To be able to get the screen to be darkened, it makes a huge difference, especially when you're trying to take a picture of a screen. So this time I kind of screwed up that way, but like I said, I was out there when I realized that I didn't bring it out and the sun was already getting between the houses and stuff. I thought by the time I grabbed something dark to put on the bottom of it, it would be too late and I would miss some shots. So I decided to try it without. The next time I do it, I'm going to go to the dime store and the dollar store and pick up one of those plastic black tablecloths and lay it on the top of the same table and do it that way. What is he saying? You believe there's more than one universe? Okay, so Hades, I don't know if you have audio problems, but I can't read all this. This is a lot of talk. The evidence is leaning towards what? It's amazing how insignificant we are. Okay, so let's scroll way back. Okay. suspend you in time. You believe there is more than one universe. Okay, Hades. It's all very interesting, but you're inundating us with questions that are kind of off subject. So again, I think I'm doing all the talking, so I think I'm gonna be quiet for a minute. And if is anybody out there that has any questions, maybe you want to ask me to show a particular picture or anything that or any specifications on the telescope or anything like that. Okay, well, to avoid the dead silence, I'm going to say, is there anybody want to discuss anything about the particular sun today, that is the sunspots that we do see, the magnetic disturbances, as we call them, the cool spots, or whatever you want to call them? Does anybody want to mention the filament that they were showing on the YouTube feed? I may be able to actually find that. We can see how similar the sunspot pictures are. If I can find that news feed, let me see. Home. Let me see if I can find that news feed without getting disconnected. I am attempting to not give this video dead space, so I'm going to sort of just say things that I'm doing to fill up the dead space while I look for that news about the solar filament that they've been following for the last couple of weeks. Perhaps I can find it on my profile page, because I think I shared it. Let me scroll down a little bit more before I give up and go to my profile. Perhaps. Okay, so I'm going to go to my profile and see if I can find it there. I'm pretty sure I would have shared it. Yes, there it is. Okay, so let me pull up this picture. This picture is from a person who shared, Michael H.F. Wilkinson shared this photo from, let me just go ahead and share the screen. This is not my photo, just for a disclaimer, because I am doing this live, but I did want to point out that these filaments on the sun have been showing up in the last couple of weeks. I'm pretty sure that the sunspot we're seeing on my photos are either the one on the left or center one. This is an older picture, so it's hard to say exactly which one of these, if either one of them were, in fact, the ones that we're looking at. I'm going to assume the ones on the top left, because this photo is obviously days before mine, because mine was actually today.
Is there any idea on what those are?
They're calling them like plasma filaments, almost as if they're like solar flares that got stretched across or something to that effect. I'm not exactly sure, but they've been following these for a couple of weeks, and it is somewhat of a new phenomenon to them. It's pretty amazing. I mean, these are obviously very nice, sharp pictures. These are obviously satellite pictures. You know, I can only wish that I can get like 1/3 of this kind of detail. But nevertheless, they're calling it the main attraction was a huge filament that made another appearance that spans more than 1 million kilometers on the surface. This is a 21-pane mosaic made with the usual APM 80mm solar spectrum setup. The person who did this obviously took it straight through the telescope, obviously superior than trying to take pictures with a small camera on top of a screen, so which is one of the things I wanted to do. But in any case, you could see the solar prominences and flares on the edges of the sun things like that. But I think that this sunspot area may actually be what I was looking at in my photos. If I can go back to that.
Did you just change a setting or something?
I just closed it off because I didn't want to share it too long because it's not my stuff. I don't know.
Oh, okay.
Yeah, I stopped.
No, because your voice got a lot clearer all of a sudden.
Did it?
Might be the bandwidth. Yeah.
Really? Was I not sounding clear before?
It sounded a tiny bit muffled, but I think that's just bandwidth because when you were screen sharing, that takes up more bandwidth. But
That's
anyways, yeah, that's really.
yes. I did notice that yesterday when I stopped screen sharing. Certain other things would get better. Yes, that's very interesting. You should say that. So okay, so if we could remember what that photo looked like, and if I can go back to my Hangout screens, or rather my latest solar projections, come up with the fixed one. See, that's the sunsets I've been seeing. Maybe not. Maybe it's not the same one. I don't know. We're talking like a week later, I think. So it's probably not. But there was the I don't want to go back and forth to different folders. But last year's project, I have a whole folder with last year's project, and I was able to show. They actually had a numbers, area 2243, I think it was, and stuff like this. I was able to show the difference between the satellite image and my image, and back and forth. And I was showing the same exact sunspots, slightly different from each other. That is, they might have been only hours behind each other. And there were some changes in those few hours. And it was really cool to do that. But, damn it, I forgot the website. I'm sure I saved it in my favorites. Am I sharing this yet? No, I'm not. Sorry. Let me go ahead and share this. Okay, so yeah, there's the one I took today. Okay, and I don't know if is that sharing? Did I change the share?
Still looks like the same image of the sunspot.
It's my image, right? Okay, so we're gonna go ahead and change that share. Okay, so take a good look at that, and then I'm gonna quickly try to see. So that's really difficult to tell because the images are such a difference in quality that you can't really put a finger on it, because I'm thinking that maybe this one got rotated around and spread out. But there is a website that I can go to, if I can remember which one it was. I'm sure it's in my favorites. Let me close that off. That actually would be able to show me today's sunspots, maybe at least yesterday's. But I should have thought of that before I started this live broadcast. So since we lost Hades, I don't know what he was up to. To tell you the truth, I don't know why he didn't open up his audio. So I don't know what his thing is. But in any case, since we lost Hades, I think I'm going to go ahead and I think the subject matter has been laid out. And
yep.
I want to thank you, Abraham, for sticking with me from the beginning.
Yeah, no problem.
And I'm going to just stop broadcast.
All right. Yeah, it was fun.